My name is Earl Gobble, and this is my presentation on proton mass. My problem, the marked mass contribution. My unique problem asks us to calculate the tiny fraction of the proton mass that comes from its valence quarks, 2 up and 1 down. This is highly relevant to our project. It directly confronts the central mystery of the proton's mass. Where does it come from? In part B, I introduced quantum chromodynamics, QCD. This problem provides the numerical basis for why QCD is necessary. It shows that the mass is not from the parts, but from the energy between gluons and quark motion. Skills gained from this problem. Understanding and solving this problem builds critical skills in physics. Differentiating between rest mass of quarks and emergent mass of the protons, building intuition for mass. Energy equivalence is E equals M. Tackling other problems. This understanding is the gateway to high energy particle physics. It helps explain how new massive particles are created for pure energy in colliders like LHC, which I mentioned in part B. Developing a unique problem. I developed this problem from scratch to connect my part B, introduction of quarks in QCD, to a real numerical calculation. Not too simple. It is not just what are the 3 quarks. It requires calculation and percentage of comparisons. Not too difficult. It uses standard concepted values for quark masses and does not require complex QCD field theories. How this problem is different. A common textbook problem might be list of quarks in a proton. My problem is unique because it highlights the paradox of the proton mass. It forces the solver to confront the fact that 99% of the mass is missing from the components. It goes beyond common problems by numerically demonstrating emergent mass, the idea that mass arises from the kinetic energy of the quarks and the binding energy of the gluons, as described by QCD. Proton mass composition. This chart visualizes the data from the problem. The quark mass slice, which is approximately 1%, is what we are calculating. The other 99% is emergent mass from the strong force. This relationship shows that the proton's mass is far greater than the sum of its parts, which is the core concept of my problem. Your quark rest mass is 1%. Your quark kinetic energy is 32%. The gluon field energy is 36%. And your QCD trace anomaly is 31%. Here's a few steps for the calculate the sum of your quark masses. Also, here's a calculate percentage of your total mass. Step 3, only 1% of your proton's mass comes from the quarks, and 99% comes from the kinetic energy of the quarks and the binding energy of the gluons, which is QCD. Verification of solution. The result of -1% of the standard accepted value in particle physics. This confirms the calculation is correct. Reasonableness, the answer is a very small percentage, which is the entire point of the problem to show that quark mass is not the main source of the proton's mass. The units MeV, C2 cancel correctly to produce a dimensionless percentage, and then value to project. This solution is the key numerical demonstration of our topic. It proves that proton's mass is an emergent property from the strong phase energy, not a simple sum of parts.